Welcome back to another video as we're looking at things we need to know before solving systems of equations. Today we're going to be looking at solving for a variable. This is going to be key to one of the methods that you use to solve systems of equations. So let's do a quick reminder. What in fact are variables? These are any letter used in the place of an unknown or changing value. Much of algebra is spent looking at variables and solving for variables. Sometimes we're solving for a number, but sometimes we're doing what we're doing today, which is to solve an equation so that one side is one variable and everything else is on the other side. So the first thing is you got to know which variable you're trying to solve for. You would hate to do a whole bunch of work and then figure out that you solve for the wrong variable. In the first step of solving, we are going to look for any terms that do not have our variable. And we're going to use the addition or subtraction properties of equality to move those terms to a side that doesn't have our variable. Then we have to get rid of any coefficients on our variables. So that's where we're going to use the multiplication or division property to solve or to get rid of any of those coefficients so that we can get our variable by itself. And if any simplification needs to occur, make sure you do that. So here's some examples. I have the exact same equation, but we're going to look at how we solve for each of the variables. It's going to be similar steps with different outcomes. Let's start with solving for y. So in this equation, 3x minus 2y equals 6, we have a term 3x. That does not have a y in it, so I want to get that to the other side. So because it's a positive 3x, I'm going to use the subtraction property of equality to move it to the right side of the equation. And that gives me negative 2y equals negative 3x plus 6. Now that I've moved all the terms, I now need to get rid of that coefficient of negative 2. So to do that, I'm using the division property of equality to divide each term on the right side by negative 2. And it looks like this. Now, I have two fractions, and I need to consider, can they be simplified? Well, the first fraction, negative 3 over negative 2, since I have a negative and a negative, I can eliminate the negatives. And the second fraction, 6 over negative 2, I treat that like division, and it becomes a negative 3. So my final answer is y equals 3 over 2x minus 3. Very similar to what it would be as if we're trying to solve for the slope-intercept form of an equation, something to keep in mind. Okay, what if we need to solve for x? Well, same idea, except now we want to start by moving the term minus 2y to the other side because it does not contain an x. In this case, though, I'm going to need to use the addition property of equality since it's a minus 2y. So I add it to the right to both sides to get 3x equals 2y plus 6. Now I need to get rid of that coefficient of 3, so I divide both terms on the right side by 3. And when I do, I get x equals 2/3 y plus 6 over 3. And this time, the only fraction I have to simplify is that 6 over 3 to get x equals 2/3 y plus 2. So, as you can see, we can solve for any variable. As long as we know our properties of equality, we can use them to solve for anything, any variable that's inside that equation. Also, did you notice how it sort of looks like how you might solve for literal equations? Yeah, there's a lot of overlap with some of our algebra skills. So the same skills we learned for solving literal equations are the same skills we use to solve for a variable. I already talked about turning an equation into slope-intercept form. Those are the same skills as solving for a variable. So we have a lot of overlap. Keep that in mind so that you remind yourself how much you really do know as you're working on your problems. Once again, thanks to SlidesGo for helping me with my videos. and my slides.